Hey, what's up? It's your old pal, Mr. Cook. We just finished up the first page of the Unit 7 extra review, where we worked on identities and simplifying. Now we're on to the second page, which focuses on solving and using formulas, it looks like. Okay, so just make sure that you have out your double angle formulas, your half angle formulas, and your identity sheets, and having out a unit circle would probably be pretty helpful as well to answer some of these. Okay, so the first one, number 16, says that we need to find all of the solutions, all of them, over the interval of 0 to 2 pi for this expression. So we need to solve for t when you get t all by itself. So right now, like, you can already answer part of this because you know that, like, you need to find angles that give you a tangent that's the square root of 3. So if you look on your unit circle, and, you know, take a couple seconds to, like, look over it, like, find your tangents and all that stuff. What angles would give you a tangent that's the square root of 3? So, you know, you look around on it and you should see that the ones that give you a square root of 3 are pi over 3 in radians, and then also 4 pi over 3, again, in radians. So these two angle measurements are going to give you two solutions if you plugged it in for the total angle. But the thing is that, you know, we need to solve for this variable, which represents the angle, but it's the angle times 3. So that means that, like, we need to set this equal to 3t still to solve for t. So the same thing with this one. So the way to get t all by itself in either case is to divide by 3. So if I divide by 3 on this one, 3t is equal to pi thirds. So if I divide both sides by 3, I get one of my answers. T is equal to pi thirds divided by 3, which would be pi ninths. Then I can do the same thing here. I just divide both sides by 3 and I get another solution, 4 pi over 9. But remember that it's looking for all of the solutions from 0 to 2 pi. So I need to find some more because this doesn't even get to, like, half of a pi, because half of a pi would be like 4.5 pi over 9, right? That'd be pi halves. So I'm not even like a quarter of the way through here. So I better find a couple more solutions for this. So the way that you find the solutions, once you find those initial two answers, you know, from your unit circle or from your calculator, whatever you use, then you need to find coterminal angles to go along with those, because those are, coterminal angles will have the same sine, cosine, and tangent as other coterminal angles. So it's always just a good idea to find a couple of them. And I'll even tell you, like, you know, kind of something to look for is look for when it says like 3x or 3t or something like that, because that'll indicate that you're looking for more than one pair of solutions. So like if you see like a 3x or a 2x or a 4x or whatever, know that you're going to be doing multiple answers. So you don't want to find coterminal angles right off the bat. So like finding coterminal angles with radians is pretty easy. You just have to remember what you keep adding or subtracting. And you know, for coterminal angles for radians, you're adding or subtracting by 2 pi. So I need to find a coterminal angle that goes along with pi thirds. So I do pi thirds plus 2 pi. And I know some of you guys hate using fractions, so what you can do is just use your calculator. All you need to do is just take 1/3. So 1/3, that's the fraction on the pi here, and then plus 2, add them up, and then turn it to a fraction, so hit math and then fraction, and 7/3. So this is the same thing as saying 7 pi over 3. So that gives you another coterminal angle, so 3t is equal to 7 pi over 3. Divide by 3 and you get another angle, which is going to be 7 pi over 3. Or sorry, 7 pi over 9, my bad. Okay, and then I'm going to find a coterminal angle with this one, so I'm going to do 4 pi over 3 plus 2 pi. And let's see what that's going to be. So 4/3 plus 2, then change it to a fraction. So I get 10 pi over 3. So that's the next angle that I can get. And do you notice like a pattern that's going on here? When like you solve for each of these, it's 1 pi ninth, 4 pi ninths, 7 pi ninths, 10 pi ninths. It keeps going up by 3 pi ninths, right? So you can just keep adding that on there. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13 pi ninths, and then 13 plus 3 would be 16. And you can double check, like, you know, you just have to find 2 more coterminal angles from there and then divide it by 3, but you'll end up with the same answer. So all 6 of these would be your solutions. All right, so that's one problem. Now for number 17, this is where they get like I don't know, I think kind of easier, because the things that are tough are finding these additional solutions, and that only happens when you have like a 3t or a 2t or whatever, or a 3x and a 2x or whatever you have. And like these next problems don't even have that, so these are going to be pretty easy to solve. So we have secant squared is equal to secant plus 2. This is a quadratic, but whenever you have a quadratic, you want to get it in a standard form, which means that it's equal to 0. So you want to 0 out one side. So I'm going to move both of these over to the other side. So I get secant squared of x minus secant of x, and then minus 2 equals 0. Now this is a typical quadratic, so I can factor it. So I need two numbers that multiply together to be negative 2 and add together to be negative 1. So those two numbers would be negative 2 and positive 1. So I'd get secant of x minus 2, and then also secant of x plus 1 equals 0. Then I set each of these parts equal to 0. So secant of x minus 2 equals 0, and secant of x plus 1 equals 0, and then solve. So add 2, secant of x equals 2, subtract 1, secant of x equals negative 1. And then secant, secant is not on your calculator, it's not on your unit circle, but cosine is. So use the reciprocal identity to show that to find the same exact angles, you would just do the cosine of x is equal to 1/2, so the reciprocal of 2. And then you do the reciprocal of this one also, so the cosine of x is equal to, and then the reciprocal of negative 1 is negative 1 still. So then you can just go on your unit circle. So hunt down these values. Ready? We need to find angles that have a cosine of 1/2, so look on your unit circle. What are those two angles going to be? So one of them should be pi over 3, and then the other one should be 5 pi over 3. And then we need to also find angles that have a cosine that's negative 1. So look on your unit circle, find the cosine where the cosine is negative 1. So that should be pi. And these are your three answers that span 0 to 2 pi. That's it. Okay, now let's go on to this one. So we have cotangent squared minus tangent squared. What I would probably do here is, let's see, what would it do? So you can do a bunch of like identity stuff here, but I probably wouldn't do that. What I would do is I would add the tangent squared over. So this would be cotangent squared equals tangent squared. And then, you can do a couple of things. You can like turn it into, I guess you could, I don't know if I want to go the sines and cosines route. Like I already know what this is going to be, because the only place where angles have the same cotangent and tangent are when, if the reciprocals are the same. And the only time that the reciprocal is like equal to itself is if it's 1 or negative 1. So like this is just asking you to find all the angles that have, a tangent that's either 1 or negative 1. So that'd be like, if you look on your unit circle, that'd be pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. And like those would be your answers, because you can like just think about it logically. When is tangent ever equal to its reciprocal? Like the reciprocal means like 1 over the number. So the only time that happens is if like your tangent is 1, then the reciprocal is 1 over 1, which is still 1. And then the cotangent would be equal to 1 as well, right? Negative 1 would also give you the same reciprocal value, right? Because that'd be 1 over negative 1, which is still negative 1. So see, like those are the only angles where you actually get the cotangent is equal to a tangent squared. There's like another way to do it, and I'll show you real quick. But it can just be really easy if you just think about it. But cotangent and tangent, those are quotient identities. So that'd be cosine squared over sine squared, and then sine squared over cosine squared. So if I cross multiply, I get sine to the fourth is equal to cosine to the fourth. And if I take the fourth root of both sides, then I get sine of x is equal to cosine of x. But like, it's their plus or minuses. So you just have to find where sine of x and cosine of x are like either the same or they're opposite of each other's. Oops, cosine of x. Or if they're opposite of each other's, like if the sine of x is equal to the negative cosine of x. And again, those values would be the same thing. Pi fourths, 3 pi fourths, 5 pi fourths, 6 and 7 pi fourths. All right, so that answer is number 18. Now let's go ahead and do number 19. So number 19, all I'd have to do is factor out a cosine. So that would be cosine, because notice you have a cosine of x on both of these terms. So if you factor out the cosine, then you get 2 sine of x plus 1 equals 0. So these are factored expressions, so I can set each of them equal to 0 and solve. So if I set cosine of x equal to 0, that is going to give me 2 answers on my unit circle. One of them would be at pi halves, or 90 degrees, and then the other one would be at 3 pi halves, or 270 degrees. And then the other one that I get is 2 times the sine of x plus 1 equals 0. And then I'd solve it, so I'd subtract 1, so 2 sine of x equals negative 1, and then divide by 2. So sine of x is equal to negative 1 over 2. And then, let's see here. I need to find angles that have a sine that's negative 1 over 2. So if you look on your unit circle, you can find those pretty easily. That's going to be 7 pi over 6, and then also 11 pi over 6. So it's going to be like all 4 of these are your solutions together for number 19. And let's see. Yeah, so just those 4 answers would work from 0 to 2 pi. All right, let's finish up number 20, and then I'll start up a new video after that. So number 20, it says sine of x is 3/10, cosine of x is negative square root of 91 over 10. So like if you use your unit circle diagram, the only place where sine is positive is in the first or second quadrant. The only place that cosine is negative is in the second and third quadrant. So like if you put those together, where sine is positive and cosine is negative is only in the second quadrant. So what you can do is just build a triangle off of that, and always make one of the sides the x-axis, always. It's because like this gives us the location of the angle that we're looking for, and it also tells us a lot about the sides and stuff. So if I know that sine is 3 over 10, then the opposite side is 3, and the hypotenuse is 10. And then if I know the cosine is negative 91 over 10, that's adjacent over hypotenuse, so the adjacent side is negative square root of 91. And that ends up working out, on your unit circle, and with Pythagorean theorem, obviously. Now, if we need to find tangent, tangent of x is going to be equal to the opposite side, which is 3, over the adjacent side, which is negative square root of 91. And that is your answer right there, 3 over negative square root of 91. Just find the tangent. All right, the next couple problems go really fast because we're just using formulas, but we'll wait till the next video to get to those. All right, so on to the next one.